Hi. So today we're going to be continuing looking at the discriminant as well as our quadratics. We're going to look at solving them. So here they're saying to graph our x squared minus x minus 6. So with that, if we graph it, I'm just going to draw a rough sketch. What we're going to see is if we plug in 0 for x, we're going to get negative 6. If we plug in 1, we're going to have 1 minus 1 minus 6. So 1 minus 1 is 0. 0 minus 6 is going to give us negative 6. If we plug in 2, we're going to get 4 minus 2, which is 2, minus another 2, which is negative 4. If we plug in 3, we're going to get 9 minus 3, which is 6. 6 minus 6 is 0. Our quadratic is going to be the same on both sides of our reflection, which in this case we're going to have some point that is going to be down here. So we have 0, negative 4, negative 6 below it, negative 6. Then at negative 1, we're going to get negative 4. And then at negative 2, we're going to end up getting our other 0. So this is going to look something along lines like that. So they're asking, and then this is our x squared minus x minus 6, y is equal to. How many x-intercepts do you see? We see 2 real roots, which means when we do our discriminant, we should end up getting a positive. What are the x-intercepts? Write them as ordered pairs. So we have negative 2 comma 0, and we have 3 comma 0. So we should get our x is equal to negative 2 and x is equal to 3. So solve any way you choose. So over here, this one we can solve using our quadratic formula, or we can actually solve just using factoring. So we know that we need to multiply to get to negative 6, which means that our signs are going to be different. We want to add to negative 1. So what's going to multiply to negative 6 is 1 and 6 with different signs, or 2 and 3 with different signs. We want to get to a negative, so the higher number has to be the negative. That means we're going to have a positive 2 and a negative 3. So that's telling us 0 is equal to x plus 2, x minus 3. Now remember, we have two things that are multiplying to equal 0. We're going to have to do our t-chart. So either x plus 2 is equal to 0, or x minus 3 is equal to 0. Subtract 2 on both sides. That's going to give us x is equal to negative 2. Add 3 on both sides. That's going to give us x is equal to 3. Notice we got the exact same solutions as if we graphed it. So we got 2 real solutions. Our solutions are x is equal to negative 2 and x is equal to positive 3. What do you notice? The solutions are the same. And I'm talking about the solutions. So here they're asking us about the discriminant. So we have our a is 1, our b is negative 1, and our c is negative 6. So remember, our discriminant, the formula is b squared minus 4ac. So this is going to give us negative 1 squared minus 4 times 1 times 6. If we simplify that, negative 1 times negative 1 is positive 1. Negative times a positive is a negative. Negative times a negative, that should be a negative 6, is a positive. So that's going to give us plus 4 times 1 is 4. 4 times 6 is going to give us 24. So our discriminant is 25. So the value of the discriminant is 25. It is positive. So remember, we said when we have a positive discriminative, we're going to end up with 2 real solutions. If we take a look at another example, let's take a look at this one. So over here, when we try to graph it, it's going to be way off the graph up here. If we plug in 0, we're going to get 25. If we plug in negative 5, that's going to be 25 plus 25 is 50. Minus 50, that's going to end up giving us 0. If we plug in, let's say, negative 10, that's going to give us 100 minus 100, that's going to give us 25. We'll see that it's going to be somewhere up here. Somewhere up here should be even, but I can't really draw it even the way that it is. We're going to end up seeing that it's going to be somewhere along the lines. Again, I'm just drawing a rough sketch like this. So we can see that we're really only going to have, if I drew this correctly, one intercept. We're really only going to have one real root. Which our answer is negative 5, 0. And now that I look at it, we can see that this is a perfect square trinomial. Remember, we said that our perfect square trinomial, that if we had ax squared plus 2ab, what was it? It was, sorry, a squared. Let me rewrite this. If we had a squared plus 2ab plus b squared, that was our example of our perfect square. And that can be factored as a minus b squared. So if we take a look at this, we're trying to multiply to 25. If we want to do it this way, we'll see that it's going to factor into our perfect square trinomial. And we want to add to 10. So it's going to be either 1 times 25, which isn't going to work, or 5 times 5. That's what's going to work for us, and it's both going to be positive. So when we bring it to the side, we're going to find that our 0 is equal to x squared plus 10x plus 25 is going to factor into 0 is equal to x plus 5 times x plus 5. That's going to give us x plus 5 is equal to 0. X plus 5 is equal to 0. Subtract 5 on both sides. And we're going to get x is equal to negative 5 and x is equal to negative 5. That's the same answer. So we really only have one real solution. So the solutions are x is equal to -5. We have one real root. We talked about our special name for it beforehand. Just remember that it's one answer. If you have the same thing, it's our double root, our perfect square trinomial. And what we're going to find out is we're getting one root because our discriminant is going to equal 0. So our a is 1, our b is 10, and our c is 25. Our formula for the discriminant is b squared minus 4ac. This is going to give us 10 squared minus 4 times 1 times 25. This is going to end up giving us 100 minus 100, which is going to give us 0. The value of the discriminant is 0. It's 0. That's why we only have one root. If anyone has any questions, I'm going to be doing Google Meet at 1. So if you have any questions, please make sure you ask in the Google Meet or post comments on Google Classroom. So if you have a question, just make sure that you ask. Thank you.